So there are kind of four physical characteristics of fertiliser. One is the shape of the individual granules. The second is the actual bulk density of the fertiliser product. So that's bulk density is the weight for a given volume. So generally what we do is we find a weight for 1 litre of fertiliser. So we're using this graduated cylinder here. The third is where we actually measure the hardness of the granules, because we want granules to be a certain hardness to withstand the impact of the vanes of the fertiliser spreader, so that we can actually propel them out to the distance that we want them to go. And then finally, the fourth one is the actual particle size distribution. So this is actually looking at the actual diameter size of the fertiliser product. So what we'll start at first is we can't actually kind of measure the shape of the granule, so that's more of a subjective thing that we can actually look at it. But we can see with these granules here, this is Yarra Mila extra grass. We can see these granules, a round granule, so they're not angular or they're not very smooth. They're slightly rough, but they're a round granule, so they're very consistent in their shape. So on some spreader manufacturers will require you to actually enter the actual shape of the actual fertiliser granule. Then when it comes to the actual bulk density, this is a very important measurement. So what we do here is we fill a 1 litre tube. It's 1 litre up the top. So what we do is we weigh this 1 litre tube, or this 1 litre graduated cylinder. So it's weighing 1.2 kilos. So that's for the actual fertiliser and the actual tube itself. So what we do is now we have to get a tear on the actual graduated cylinder. So we empty it. So we get a weight for this. And this is weighing 0.2 of a kilo. So we deduct this tear weight from the initial weight, which is 1.2 kilos. So the actual what we get is 1 kilo. So pretty much this product is 1 kilo per litre. So the bulk density of this extra grass is 1. So the next one we move on to here is looking at the actual the hardness of each individual granule. So we use this hardness meter. So this hardness meter is able to you're putting pressure on the granule, and it's getting the pressure increases as you force down it, and then you're able to record then the point at which the actual granule shatters. So we take 10 different granules and we force down on it. So you're looking for that characteristic pop, and you're taking a reading then. So this one has a reading of 5. So we do that then for 10 different granules. So that one is 6. That one is between 8 and 9. That one is 5. So we keep doing that until we've 10 done, and then we get an average of what the actual 10 readings are. So we're looking for the average to be over 5, a minimum of 5, so that the actual granule can withstand the impact of the vanes, and so it can spread to the maximum width of the capabilities of the spreader that you're using. So the last one we use is this actual grader box. So we're looking at the particle size of the actual individual granules. So what we do is we fill one compartment up, so then with the fertiliser, and then we turn it around and we shake it, and then so the particles then get separated into different diameters. So what we do then is turn it up, and then we can actually read the actual the sizes of all of the particles. So we can see here with the greatest from between the, particles with a diameter of greater than 4.75, we can see that there's probably less than, there's probably 2 or 3% there. We can see where, and this is kind of the desirable range here, this 3.3 to 4.75. So we can see there that we've slightly more than 60% there, maybe 62 or 3% there that are falling into that size category. And then for the next size category between 2 mil and 3.3, it's falling into around about 25%, and then we've none then at this 2 millimeter size. So we don't want to see particles arriving in there, because those particles don't have the weight to be able to be carried over the the distances that fertilizer spreaders are able to apply them. So you're looking for a distribution between these two particular sizes here. So we'd like to have the vast majority of our particles between 3.3 millimeters in size and 4.75 millimeters in size. There are the four. There's measuring the three of the physical characteristics of fertilizer, and with I suppose a compound fertilizer, Yara's compound fertilizers, there is I suppose a consistency there that you don't have with blended products, because blended products you're using individual ingredients that have different physical shapes, but also different bulk densities, and also different hardness and different size distribution. So it's very hard then to actually come up with a setting to have them that they'll spread each individual nutrient evenly over the full spreading width.